Hey there, people watching this video, taking notes hopefully. All right, it's time for another lesson. We're going to go ahead and continue our nice little stroll through chapter 12. This time, section 2, we're going to talk about frequency and histograms. Frequency and histograms. Our objective for this lesson is to make and interpret frequency tables and histograms. And this is a pretty easy lesson. Pre-algebra, chapter 12, they kind of cover the same thing. So hopefully this is largely a review for you guys. Now, there are many ways to organize and visually display data. And this is important. Why is this so important? Well, if I just gave you guys data, just numbers about random things, you guys would largely be uninterested, unless you have some sort of problem where you guys are really interested in boring things like numbers, just kind of just out there, then it doesn't really mean anything. If I just give you a bunch of numbers, it doesn't mean much. But if I take this data, if I take any information, which is important because the world that we live in today is kind of built around data, whatever job you get in the future will likely revolve around data and collecting it. Unless we make it more appealing and easy to understand, it's really a hindrance to us in our daily lives. So if I can take data and put it into a table or draw out a picture that makes it a little bit easier to understand, all of a sudden these numbers mean something. And that's what we want to do with today's lesson. We want to take numbers that largely would be a mess if we just looked at numbers by themselves and then make them a little bit easier to understand, a little bit more digestible. All right, so here's what we're going to talk about. We're going to talk about the word frequency. Frequency means like the amount of times something happens. If something happens very frequently in your life, like maybe Mr. Lopez frequently makes jokes that nobody laughs at. All right. If it's a frequent thing, if it happens all the time, all right, one, that's bad for Mr. Lopez. Two, that's bad for the people that have to hear his jokes. All right. Three, Mr. Lopez should probably take the hint that jokes aren't his thing. All right. We can use that information and we can take these trends, these patterns, and we can actually impact our lives. Now what we're going to do is we're going to go ahead and look at problem number 1, and we're going to make what's called a frequency table. We're going to look at some data, some numbers, and we're going to figure out, well, how often does something happen? Problem 1, making a frequency table, uses a baseball statistic as an example. The number of home runs by batters in a local home run derby are listed below. What is the frequency table that represents the data? So here they said that one batter hit 7 home runs, the next one hit 17, 14, 2. What a loser. Just kidding. More than I've ever hit. I'll tell you a true story. The best I've ever hit when playing baseball was a triple one time in my life. And I think I got there because of errors. I honestly was not a good baseball player. 7, 9, 5, 12, blah, blah, blah. These are all the home runs that people hit. Now, these numbers, looking at them, you might be able to get like a good picture out of this. You might be able to get something out of it. But it would probably be in our best interest if we organize this into a table. So what we're going to do is we're going to make what's called a frequency table. Okay? Now, what we want to do is we want to organize it into something that looks like this, where we can easily identify the range of home runs that people might have hit, and then the frequency at which they hit them. How many people hit 2 to 5 home runs? How many people hit 6 to 9 home runs? How many people hit 10 to 13 home runs? Or how many people hit 14 to 17 home runs? So what we're going to do is we're going to look at this data, and the first thing we want to figure out is what is an appropriate range that we should go ahead and pick. All right, the smallest number of home runs that somebody hit was 2, and the largest number of home runs that somebody hit was 17. So if we count the numbers between 2 and 17, you guys can use your fingers. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We figure out that there are 16 different numbers between 2 and 17. All right, you might do simple subtraction and get 15. Be incorrect. Go ahead and count it again. All right, it's going to be 16. Now, because there are 16 different numbers in between these two values, what we can do is we can divide each of them by 4. We could have range of 4 home runs each little section. So 2, 3, 4, 5, there's 4 home runs. Then 6 to 9, 4 home runs. 10 to 13, 4 home runs. 14 to 17, 4 home runs. And then we count how many people hit between 2 and 5 home runs. Well, this guy hit between 2 and 5. This guy hit between 2 and 5. 2 and 5. 2 and 5. And there were 4 of those numbers. And then we can go ahead and just kind of I can use a different color. How many people hit between 6 and 9 home runs? Well, this guy hit between 6 and 9. This one. That one. And this one. And this guy right here. Alright. 4 guys hit there. How many people hit between 10 and 13 home runs? Well, between 10 and 13 would be this guy right here, this guy right there, that guy right here. There were 3 of them. And then how many people hit between 14 and 17 home runs? Well, 1, 2, 3. There are 3 of those. And that's a frequency table. That's all you have to do to make a frequency table. All right? Make sense? Okay. Now, what if I wanted to kind of rearrange these numbers? What if I wanted to take these numbers and rearrange them in intervals of 5? Well, here I have a frequency table set up for intervals of 5. Intervals of 5. Each little interval right here, 1 to 5, has a possibility of 5 possible home runs. I could have set this up as 2 to 6 and so on, but this seemed like it made a lot more sense to set it up 1 to 5, 6 to 10, 11 to 15, and 16 through 20. So all I'm going to do is go through my list of numbers and figure out how many of these are between 1 and 5. So looking at 1 through 5, let's go ahead and circle the numbers that are between 1 and 5. Well, this guy is between 1 and 5, between 1 and 5, between 1 and 5, between 1 and 5. It looks like I have 1, 2, 3, 4 between 1 and 5. Then I can go ahead and look at the numbers between 6 and 10. Between 6 and 10, this guy, this guy, this guy, and this guy. 1, 2, 3, 4, 5. This has a frequency of 5. And then we can go ahead and look at the numbers between 11 and 15. Between 11 and 15, 11 and 15, 11 and 15, 11 and 15. So there are 4 there. And the numbers between 16 and 20 looks like it's just going to be this one guy left over. Only one person hit between 16 and 20 home runs. Now, if we did this right, we should be able to add up the frequency, and we should have the same amount of number here. 9, 10, 14, and there should be 14 points of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm sure it was really exciting watching me count to 14. The suspense might have been killing you, but we made it. All right, so this is an example of a frequency table. Now, you might have in the past used tally marks in order to count these. It's probably better for us just to cross off numbers as we go along and then double check by counting and adding them up. Now, you might be asking yourself, well, what are we going to use these frequency tables for? Well, we can use these frequency tables to make what's known as a histogram. A histogram is a graph that can display data from a frequency table, and it has one bar for each interval. Instead of each bar representing a certain number, it represents the range of numbers. Now, here's an example for problem 2, where they're using this data and they're making a frequency table for the number of hours that people are watching television. All right, so the group of students there are 6 students that spent 0 to 5 hours watching television, 5 students that watched this much, 3 here, and 1 student that watched 18 through 23 hours. That's probably me. Just going to be honest with you guys. I watch a lot of television. Now, this might mean something. You might actually be able to look at this graph and this table and actually get some data out of it. But maybe a picture might be better. Some people might enjoy looking at numbers. Some people might prefer a graph like this. And this is an example of a histogram where you would graph on the x-axis the range. How do I know that this is the x-axis? Well, because remember, we read graphs from left to right, top to bottom, and alphabetical order, x goes first, so this would be our x-axis, and this should be our y-axis. Notice that they labeled the hours and frequency, so this means something, and they even labeled the entire graph just so that we know what we're talking about. In this case, we're talking about watching television. Right? And then they just graphed it, and they just made sure that 6 was a number of frequency of people that watched this much, and so on. So really, not too hard. You take the information, you put it into a frequency table, and then you can make an appropriate histogram. Here we have got it question number 2, where they give you the finishing times for a race that's recorded in seconds. And I already set up our frequency table. I looked at my smallest number is about 80 seconds, and my largest number was about 105. So I went ahead and set up my increments in groups of 5. And I'm just going to go ahead and count how many times each one is used. If you wanted to, you could use a tally mark and say, well, 95 will go in this tally and everything. I'm just going to go ahead and count my groups of 80 to 85. So groups between 80 and 85, 1, 2, 3, 4. So I have 4 there. All right. And then if I miss one, I can always go back and add them to it. So 86 through 90, any numbers between 86 and 90. I got 1, 2, 3. So I'm going to put 3 there. Now groups between 91 and 95, 1, 2, and that's it. So 2 of these guys. Groups between 96 and 100, 1, 2. And then groups between 101 and 105, it looks like there's 2. So my highest amount of frequency is 4, so I'm going to go ahead and separate this in groups of 1, 2, 3, 4. And this first guy has a total of 4. The next group was at 3. The next group, all these other groups were at 2. 2 and 2. I have my ranges, and I have here, and I can set this, and I can label this finishing times for the race. Cool? Cool. Now you can also describe histograms in terms of their shape, where if the bars of the histogram roughly are the same height, we're going to call that uniform. If you have them so that there's like a peak in the middle, and it's almost symmetrical on both sides, we're going to call this symmetric, all right, where it's kind of close to a mirror image on both sides. Or if the histogram has one peak and it's not in the center, then we're going to call it skewed. Skewed. So we have 3 terms: uniform, symmetric, and skewed. So looking at this, how would we classify this as uniform, symmetric, or skewed? Well, it looks like the peak's in the middle and they're almost mirror images of each other, so we would call this symmetric. All right, looking at this one, we can see that the peak is off center. It is definitely not uniform, so we're going to call this skewed because the peak is not in the center. So if asked to make a histogram and then describe the shape, you can use those 3 terms. The very last thing that we can talk about is something called a cumulative frequency table, where if you are given values, you can make a normal frequency table with those values. But a cumulative frequency is just adding the numbers as you go along. For example, there were 11 in this frequency range, and then there are 3 in the next one. So all I'm going to do is add 3 to the previous number. 11 plus 3 is 14. Then I add 3 more and get 17. Then I add 17 plus 2 is 19. And then 2 plus 19 is 21. And what this does is this gives us all the values that are within those range. And that can be useful depending on what type of data you are collecting. But really all you're doing is adding the new frequency to the previous frequency and getting a cumulative frequency. And that is it. All right. Have fun with this. See ya. Peace.